Hello, everybody, and welcome back. We are continuing our lessons in energy today by talking about mechanical advantage. Now, yesterday we learned about the different types of simple machines, and today we're going to be talking about how those machines make our lives easier with something called mechanical advantage. So, without further ado, let's go ahead and jump into it. Now, we know that simple machines can make our lives easier, and they do that in three ways: by increasing the force that can be applied to an object, by increasing the distance over which a force can be applied, and by changing the direction of an applied force. And we are going to explore those today. Now, there are two forces that are involved when a machine is used to do work. There is the input force that's applied, so the force that you apply to the machine, because anytime we use a simple machine, we are exerting a force onto it ourselves. And this is just notated as Fn, so the input force. The force applied by the machine is called the output force. So the force that is coming out is that the machine is doing, that's our output force. And then similarly, there are two kinds of work. So the input work, the work that we do on the machine, and then the work done by the machine, that is the output work. So input is the work that we do on the machine or that's done by yourself, and then the output work done by the machine is W out. Now keep in mind that energy is conserved. So when we do work on a machine, we transfer energy to the machine, and then the machine does work on an object. That energy is transferred from the machine to the object. Now keep in mind the amount of energy that the machine transfers to the object cannot be greater than the amount of energy you transfer to the machine, because energy is conserved, right? So what you put in is what you get out. So you can never get more work out than you put in. Okay, and there is a trade-off between force and distance. So this is just showing us our conservation of energy. So the work in will be equal to the work out. And remember, the formula for work is force times distance. Okay, now we'll talk about what these little e's and the r's are in just a minute. So like I was saying, there is a trade-off between force and distance. So if the machine increases the force applied, it must be applied over a greater distance. This means that less force is needed, but the distance the force is applied has to increase. Okay, so you can make things easier and you can lessen the force required, but you would have to increase the distance over which that force is applied. Now, we saw those E's a couple slides ago in that formula that was just showing us the conservation of energy, but the E is for effort, so the effort force. This is what is applied to the machine. So the effort, think about the effort you are putting forth, that you are applying, is the force applied to our simple machine. It's what you do. The resistance force, which is Fr with that little R notation there, is the force applied by the machine. So it's what the machine does. So the effort force is what you do. The resistance force is what the machine does. And that gives us our mechanical advantage. So mechanical advantage is the number of times a machine increases the effort of force. Okay, so the number of times a machine increases the effort of force. And the way that we calculate this is our mechanical advantage is equal to Fr over Fe. So the resistance force over the effort force. Now, if you do these calculations, and you're going to come up with a number, obviously, because it's a numerical calculation, but I'm going to tell you what these calculations, these numbers will mean. So if your mechanical advantage is greater than 1, that means the force is increased. If it's less than 1, that means the distance is increased, because remember there's a trade-off between force and distance. And if it's equal to 1, that means only the direction is changed. Okay, we'll use an example of window blinds here. So blinds are a machine that changes the direction of an input force. The downward pull on the cord is changed to an upward force on the blinds. The input and the output forces are equal, so the mechanical advantage is 1. So again, the direction of the force is what's changing, right? So the input force is going down and the output force is going up. So let's take a look at some examples on how to calculate mechanical advantage. This is what you guys will have to know how to do. You need to know the definition of mechanical advantage and also be able to do these calculations. So it says a worker applies an effort force of 20 newtons to open a window with a resistance force of 500 newtons. What is the crowbar's MA, mechanical advantage? So we're given our effort force of 20 newtons. And we're given our resistance force of 500 newtons. So we need to calculate our mechanical advantage. Remember, mechanical advantage is the resistance force divided by the effort force. So our resistance force was 500 newtons divided by 20 will give us a mechanical advantage of 25. Okay, and that's how you do those calculations. Now remember, at this point we have learned how to calculate force, right? So if you had force and distance, you might have to calculate the force, but in this case we were given the actual force. And then just another quick example, find the effort force needed to lift a 2,000 Newton rock using a jack with a mechanical advantage of 10. So again, we're given our resistance force of 2,000. And we're given our mechanical advantage of 10. So in this case, we're calculating the effort force. So last time we calculated our mechanical advantage, but here we're calculating for our force of effort. So in our little triangle, this is what we're looking for. So we're looking for our effort force, which means solving for this will be our resistance force divided by the mechanical advantage. So here we've got our resistance force divided by our mechanical advantage. We've got 2,000 newtons divided by 10. That's going to give us an effort force of 200 newtons. Okay, so again, like with most of the things that we've done in this unit, it's plug and chug, right? It's just a little bit tricky when it comes to identifying the variables. That's normally where kiddos tend to get stuck a little bit, but if we really pay attention and we read through these carefully and we identify what is our effort force, our resistance force, and our mechanical advantage, we just plug and chug and use our little triangle to help us. As always, if you need help, I'll be more than happy to help you in office hours. And if not, I will catch you guys in the next one.